Hey, 7th grade. In this video, we're going to continue talking about how to solve multi-step equations. We're going to expand that a little bit in this next video and talk about how to solve equations when you have a variable on both sides of the equation. So the process of solving an equation when you have variables on both sides is really no different from the other equations. So just like in the last video, we're going to start out by simplifying each side of the equation separately. So we're going to look at the left side, do any simplifying we can, and then we'll look at the right side. Once we do that step, once we simplify, then we're going to move one of the variable parts either from the left to the right or from the right to the left by doing either addition or subtraction. And when we do that, we want to remember to combine our like terms. Okay, so let's look here in example 1, and I'll show you what I mean by that. Number 1, we have 7k plus 2 equals 4k minus 10. So again, the first thing you want to do is just look at the left side by itself first. Okay, so you have 7k plus 2 on the left. You can't do any simplifying there on the left side, so we're good with that. And now we'll look at the right side. The right side you have 4k minus 10. Again, there's no simplifying you can do. So we're going to jump right on to moving things over the equal sign. Now the first thing I want you to move is I want you to move one of the variable terms. So we're going to move either this 7k from this side to the right, or we'll move the 4k from this side to the left. I personally like to put my variables on the left side whenever possible, but it's up to you which one of these you move. So I'm going to choose to move my 4k here, and it's a positive 4k, so we're going to move that by subtracting 4k. Okay, so I want to move both the 4 and the k, and we're doing that again by subtracting. Okay, so this is where you want to be really careful. 4k minus 4k on this side is going to be 0k, so those will cancel each other out, and you're just going to get equals, the only thing left on this side is a negative 10, so we'll bring down that negative 10. Now on the left side, that minus 4k gets combined with the like term 7k. So 7k minus 4k is 3k, and then we just bring down this plus 2 here. So it's really important that you line up your like terms directly on top of each other. That way you don't accidentally combine, let's say, this 2 and this negative 4 here. Line up everything in nice columns. So now we have 3k plus 2 equals negative 10, and now this looks just like a two-step equation that you know how to solve already. So we can subtract 2 from both sides and bring down this 3k, so that gives you 3k is equal to negative 10 minus 2 is negative 12, and then we can divide both sides by 3, and that gives us k is equal to, that would be negative 4. Okay, so again, once you've simplified both sides, you want to move one of the variables over the equal sign first, and that will put the variable just on one side, and then you can solve like normal. Let's look at number 2. For this one, we have 2 times the quantity 5x minus 1 equals 3 times the quantity x plus 11. So again, you look at the left side first, and the left side here, we can simplify that. So that's the first thing I'm going to do. I'm going to distribute my 2, and that gives me 10x minus 2 equals, and then I can simplify my right side as well. So if I look at the right side here, I have 3 times the quantity x plus 11. So I can distribute my 3. That gives me 3x plus 33. Okay, now again we have a 10x on the left side and a 3x on the right, so my next step is to move one of those terms to the other side. And again, I like to move everything to the left, so I'm going to subtract my 3x from here, and then also from the left side, right underneath my 10x. Okay, so on the right side, those 3 x's will cancel, and you're left with a positive 33. On this side, 10x minus 3x is 7x and then we'll bring down that minus 2. And so now we can add 2 to both sides. That gives us 7x is equal to, this would be 35, and then divide both sides by 7, and you get x equals 5. Okay, just like for all the other equations, we do want to practice checking our answers. So to check this one, and you can do that with number 1 as well, I'm going to copy down my equation 2 times the quantity, 5, and it was 5 times x. So I'm going to plug in, we think the answer is 5, so 5 times 5 minus 1, and that's supposed to be equal to 3 times the quantity x plus 11, so I'm going to put in a 5 plus 11. So here in blue, I'm plugging in a positive 5 into both places where my x originally was. And so now if we simplify the left side here using order of operations, in parentheses we have 5 times 5, which is 25, minus 1, and then that's being taken times 2 out here, equals over here we have a 3 times 5 plus 11. 5 plus 11 is 16. Okay, and now on the left side, do parentheses again, 25 minus 1, you get 24. So this is 2 times 24, and that's supposed to be equal to 3 times 16. Well, if you take 2 times 24, you end up getting 48, so you get a 48 on the left side, and then 3 times 16 is also 48. Okay, so that's how you would go about checking when you have an equation with variable on both sides. You got to plug that 5 into both places you see x. Okay, why don't you pause the video and try examples 3 and 4 on your own, and then click play to check and see if you got the answers right. Okay, so let's check your answers and see how you did. For number 3, you didn't need to simplify either side. So the first thing you could have done was add 2s to both sides. You could have also subtracted the 5s from both sides. The way I did it though, when I added 2s, you get 7s plus 13 equals 22. Then you subtract 13 and divide by 7, and you get an improper fraction, s equals 9/7. Over here on number 4, you will need to distribute first on the left and on the right both to get 28 minus 7a equals 3a minus 12. Then you can move the variable by subtracting this 3a from both sides. Make sure you're combining it with the 7a, so that would give you a minus 10a on the left side. And then to solve, we can subtract 28 from both sides and divide by that negative 10 to get a equals positive 4. Okay, now there are a couple of what I call special cases whenever you have a variable on both sides. And so that's what I want to look at here for the last couple of examples. Okay, so there will be times when you're solving an equation and no value, okay, no number for the variable makes the equation true. Then other times you'll solve an equation and all values will make the equation true. And so again, these are called your special cases, and we refer to them as either no solution, that would be the first case when no number makes the equation true, and all reals. That's when all values make the equation true. Sometimes we also call all reals an identity, so you may see me jumping back and forth between those two terms. These both mean the same thing. So let me show you what that looks like. In number 5, we have 10x plus 12 equals 2 times the quantity 5x plus 6. So if we just look at the left side, 10x plus 12, there's nothing you can do to the left side. There are no like terms to combine. But then if we look at the right side, we see we can distribute that 2 on the right. So I'm going to recopy the left side, 10x plus 12 equals, and then on the right side I'll distribute my 2, and that's going to give me 10x plus 2 times 6 is 12. Okay, so from there, if I do the same thing we did on the front, if I take this positive 10x and move it to the other side, minus 10x, and then over here minus 10x, you'll notice something strange happens. We expect these two to cancel out, 10x minus 10x, okay, to get 0, but over here, this 10x minus 10x also cancels out. And so you end up getting 12 on the left side equals 12 on the right side. And so the point of this is the variable goes away completely when we solve this equation. Whenever that happens, that tells you that you have one of these special cases. And so now you just have to determine, is this a true or a false statement? Well, 12 does equal 12. That's a true statement. And so we would say that the answer to this is all reals. What that means is you can take any number, any real number, okay? You can take a positive number, a negative number, a fraction, a decimal, an improper fraction, and plug it in for x. And when you go through and do a check, you'll get a true statement. Okay, this equation is true for all numbers. So we say all reals. Number 6, we're going to see kind of the opposite. So again, I'm going to look at the left side of my equation, 9m minus 4, and you can't simplify 9m minus 4 at all, so then we'll look at the right side. We have negative 3m plus 5 plus 12m. You can combine like terms there. Negative 3m plus 12m is 9m. And then we'll bring down our plus 5. So we have 9m plus 5 over here. And that's equal to, on the left side, we had that 9m minus 4. So I see a variable on both sides. Again, I want to move that variable to one side first, so I can subtract this 9m over. And we'll see that the same thing happens. Since we have a 9m over on the left as well, these cancel out, and so again the variable goes away. So now I get the statement negative 4 equals positive 5. There is no variable in this problem, but this statement is false. Negative 4 is obviously not equal to 5. So whenever you get a false statement like this with no variable, we call that a no solution. That means that there is no number you can think of to plug in for m that would make that equation true. Okay, there's no number at all that makes that equation true, so that's why we call it a no solution. Okay, the last problem, the table, we'll go ahead and we'll do that together in class. So jot down any questions you may have over this section. Again, we're getting a little bit more advanced, so feel free to ask those. And until I see you again, have a nice day. You are all wonderful people.